All right, everybody. Obviously, I'm not at school, so we're going to have to do these notes through a video. So if you do not have your spiral notebook out, go ahead and get it out. We're in Unit 5. We had set this up on Tuesday, and I know Tuesday I wasn't at school either because I had a sick child. My 5-year-old was sick. Well, this time I am sick. The sickness finally got me. And so I won't be at school today. My hope is to be back on Friday. So Unit 5, solving systems of linear equations. You guys did this one on Tuesday where you graph two lines and you look to see where they intersect. Today I'm going to show you the second way to solve systems. So in your spiral notebook, we're looking at 5.2, and we're just going to name this solving systems. Oh, sorry. And by substitution. And we're going to put this on page 40. Solving systems by substitution. This should have been taught in the 8th grade, but a lot of kids forget until they see it a couple times, so I'm hoping that's going to be what it's like for you. So, these notes should be passed out. It's just a normal sheet of paper. Fold it and then tape it down onto page 40. So we're going to pause this video, give you a couple minutes to get that done, and then when everybody's ready, we'll get back to it. Let's pause it. Everybody should be ready by now. So for this set of notes, there's not a whole lot in that box. What I tried to do is I thought about how you solve by substitution, and I tried to make it steps that you could actually follow. So there's 3 steps. Step number 1, you get to skip a lot of the time. So really it's just steps 2 and 3. But we are going to talk through these steps and do problem number 1. And here's the thing. I'm only going to go through 4 of these, and I'm just going to go over them and how to do them. So I need you to pay attention because you do have a practice assignment after this. So steps for solving a system by substitution. Step number 1, this is the one that we get to skip most of the time, is to solve one of the equations for one of the variables. So I want you to look at number 1. Number 1, we've got 2 equations, so that means there's 2 lines. We have x plus 4y equals 30 and x equals 2y. Because this bottom one, that second one, is already solved for the x variable, step 1 is done. You don't have to do anything, you don't have to fix anything. We're ready to move on into step 2. Step number 2 is to substitute the expression from step 1 into the other equation and solve for the remaining variable. So here's how this works, and this is the part that I really need you to watch. Before I can do anything, we need to make sure that you understand what substitution means. Substitution is if I take something out and I put something of equal value in its place. So I automatically think about sports because when you sub out an athlete, you're putting somebody else to replace them. Maybe they're a little bit tired and need a break, so you put in a different player. Substitutions happen all the time in baking. Like if someone's allergic to eggs, they substitute applesauce into whatever they're baking because it's got the same consistency as eggs do. So in the math world, we can also use substitution, but we're substituting numbers and variables into any given space. So here's how it actually works. This second one says x is equal to 2y. I'm going to highlight this 2y. Now, that 2y is equal to x. So that means that this x is also going to be 2y. Because I've got x is equal to 2y, I'm going to take that 2y and plug it into where that x is. So here's how it looks. So 2y, where that x was, plus 4y equals 30. And then we just solve for the remaining variable. The only variable that's left is this y variable, and so we're going to solve. You do normal order of operations. So right here, we got like terms on the same side, so we're going to combine like terms. That's going to give me 6y equals 30. To solve for that y, I'm going to divide by 6. And I end up with y is equal to 5. Now, this is an important piece of information for me because when you talk about systems, Tuesday we talked about graphing two lines on the same coordinate plane and you're looking for where they intersect, and it's the ordered pair of the intersection. This is the same concept, but not on a graph. You're solving them what we call algebraically instead. But the end result is still the same. You're still going to have this ordered pair at the end. So this y equals 5, that's going to be my second number in my ordered pair. So we're honestly, you're like 90% of the way done. The hard work is over. Step number 3 just says to substitute the value from step 2 into one of the original equations. And then you're going to solve to find that other value. And then I put it in all caps right there, which I've already talked about it. Remember that the solution does need to be an ordered pair. So here's how it works. We've got 5 as my y value. You get to pick which one of these equations that you actually want to plug it into. It doesn't matter because you're going to get the same answer at the end. But I will tell you this. Almost always, one equation is significantly easier than the other. In this case, it's the second one because it just doesn't have as many terms in it. So I'm actually going to use that second one. So x equals 2, and it was a y right there. I now know that y is 5, so I'm going to plug in a 5 right here. Anytime we say plug in, that means substitute. So we're substituting in that number. And then 2 times 5 is 10. So there's the other number for our ordered pair. So this one has one solution at the ordered pair 10, 5. And there you go. It's that same process over and over and over. And I am going to show you a couple of different examples so that way I can expose you to all of the ways that it might look. So the second one says solve the system. Both of these equations are in slope-intercept form, which means they look like y equals mx plus b. If you had a graph, this one would be a fantastic one to graph because they're already in slope-intercept form. Unfortunately, we do not have the graph, and so we are going to do this algebraically through substitution. So here's what I would do. This is what I would do to set it up. This one, the shorter one, I'm going to substitute that shorter one into this one. Now, because it says y equals negative 3x, that means that this y is also equal to negative 3x. So we have negative 3x is equal to 6x minus 9. So all I did, and I really want to make sure that you see it, that first equation, all I did was I took out that y and I substituted in its place this negative 3x. The reason is because it said right here y was equal to negative 3x, so I just did a little swap. Now we solve it. Remember solving equations, you guys have been doing this for years, so trust your gut, trust your instinct. We need to get the variables to one side. So this 6x, we got to get rid of it. I'm going to subtract. Remember, we subtract right here because this was a positive 6x, so the only way to get rid of it is to subtract. Negative 3 and negative 6 make negative 9x equals negative 9. Divide. And we end up with x is equal to 1. So in the ordered pair that we're after, this is our x value, so that's going to be the first number in this ordered pair. And then if you're tracking our steps up there at the top, we are now getting ready to do step 3, which is where we backtrack, plug it in to find that second variable. So again, one of these equations is a little bit easier than the other. Normally I try to pick the shorter equation to plug back into. That's just my rule of thumb. So we have y equals negative 3, and there's an x right there, but I just solved and found out that x was 1, so I'm going to substitute that in. Negative 3 times 1 is negative 3. So there's the other part of our ordered pair. So there's our first two examples. Make sure you have it all written down in your notes and that you have it correct. Flip on over to the inside, and let's take a look at number 3. So number 3 is about as bad as it gets when it comes to solving systems with substitution. The reason why this one is not as friendly as the first two that we did, neither one of these equations are already solved for a variable, which means we have to do a little bit of work at the front end to get one of those equations solved for a variable. Now, here's the thing. You get to pick. You get to look at these variables. We have a 2x, a negative y, an x, and a 4y. You get to decide which one you want to solve for. My recommendation is obviously choose the easier one because that's going to be just more efficient for us to use. And when you look at this, it's the second equation and this x variable that's going to be the easiest to solve. That's because there's an understood coefficient of 1 in front of that x right there, and so it's real simple to get rid of this 4y, and then boom, we're ready to go. So I do want you to make a little note, because if you need to look back at your notes, I want you to know what we did. I want you to draw a little arrow to that second equation, and let's make a little note. We are going to solve for x on this one. Once we do that, we have rewritten the second equation, and then you won't use this one again. So now we're getting ready to solve it for this x variable. To get rid of this 4y, I'm just going to subtract. That leaves me with x is equal to, these two can't combine because they're not like terms. Variables are listed first typically, so I'm going to do negative 4y minus 20. This is my new equation number 2, which means I will no longer be looking at that second equation at all. I've got the first one and my new second one. This is the one I'm going to be working with. Because now, here's the substitution part. So now this is technically step 2. We're going to take this negative 4y minus 20, and we are going to substitute it in for the x that we see, because this says x is equal to that. So for this x right here, I'm going to substitute in this negative 4y minus 20. Here we go. So 2, and then in parentheses, negative 4y minus 20, end parentheses, minus y equals 23. Now, because you plugged in something that had 2 terms in it, this one has 1 extra number that we're going to have to get rid of, but it's not bad because, like I said, you guys have been solving equations for a really long time. So, step 1, to solve this, I only see a y variable, so I'm going to end up with y equals at the end. Let's distribute. 2 times negative 4y is negative 8y. 2 times negative 20 is minus 40. And then I'm going to drop down the rest of this. So minus y equals 23. Now, this is typically where I lose a couple of kids. These two things right here, this negative 8y and this negative y, they are on the same side of the equal sign, which means you are just going to combine like terms. That means you're either going to add or subtract depending on what the sign is in between them. So when I do this, I underline them, and then I just read them. So we have negative 8y minus y. This is a 1, so negative 8 and negative 1 make negative 9. Then I drop down the rest that I didn't use. Minus 40 equals 23. Now it's a normal 2-step equation that's introduced in the 7th grade. To get that y by itself, let's get rid of that 40. Gotta add 40. We have negative 9y is equal to, that's going to be a 63. And lastly, to get that y all the way by itself, we're going to divide by this negative 9. And so I end up with y is equal to negative 7. In my ordered pair, because remember that's what I'm after, this is going to be the second number because this is my y value. So second number. And now I'm going to backtrack and plug it into one of these to figure out what that x variable is. Now, remember I always said that you want to try to choose the smallest one or the shorter equation because that's a good rule of thumb. This time they have the same number of terms in them. They both have 3 terms. I'm going to still choose to use this one, though, the second one, because this one is already solved for x. So when I plug it in, I'm only going to get a number left over. So here's that work. We have x equals -4. Where that y is, I'm going to plug in a -7. And then we have -20. Now, you can type that into your calculator, everything after the equal sign. If you're pretty decent with mental math, it's really not that bad. We've got -4 and -7. Multiplied make a 28, and then -20. So we get an 8. And so here is the ordered pair where these two lines cross, even though we do not see it on the coordinate plane. And now our last one. This is how they typically look. Like if you're getting ready to actually use substitution, this is what they look like most of the time. You're going to have one just standard form equation where you have x plus y equals a number, and then you typically have one in slope-intercept form. If this were me on a test, I would still use substitution because that would be faster for me than trying to convert this to slope-intercept form and then graph it. So again, I'm going to highlight the stuff that is already equal to. So we have y is equal to that. So for this y variable, I'm going to substitute in. We end up with 5x plus 3, and then open parentheses, because now I've got to actually plug that in or substitute it in. -5x plus 5 equals 11. Now we just solve it. So we're going to solve this. We'll do it together. If you can work ahead, please do. Try to stay in front of me. I'm going to distribute. Now this 5x up here at the front, I can't do anything with it, so I'm going to drop it down. And when I distribute, I'm only distributing that 3 right there. So, and that's a positive 3. 3 times -5x is -15x. 3 times 5 is 15. These are on the same side, so I'm going to combine them. They combine to give me this -10x. Next on my list to get rid of is this 15. Subtract. So I end up with -10x is equal to -4. This is going to give us a decimal because 10 doesn't go into 4, which is fine. Decimals are fine. So we have divide by -10, divide by -10, and then we have x equals. Now, we have a negative divided by negative, which means it's going to be a positive. If you're not very good with your decimal conversions, that's okay. Just type it in your calculator. Decimals are fine. But this is 0.4 as a decimal. So in my ordered pair over here, that's going to be my first number, 0.4. And lastly, I'm going to take that 0.4 and I'm going to substitute it back into one of those original equations and then figure out what that y variable is. Now, I'm trying to choose the easiest one for me to do. That's definitely going to be the second one because it's already solved for y. So all I have to do is plug in that x right there and then I'm good to go. So we have y equals -5. Where that x is, I'm now going to substitute in this 0.4 plus 5. So this is what we're working on. Now, several of you are not good with decimals, and that's totally fine. You're not the first kid that's not good with decimals. Just type that into your calculator, everything after the equal sign, and you should end up with a 3. So here's our ordered pair. And there you go. So I've done 4 problems with you. The 2 on the front are relatively on the simpler scale. Number 3 is the worst one. That one was the most challenging one. And then number 4 here is Normally what we see, it's either a mixture of 4 and then 1 and 2 on the front. So you need to take your notes and you need to use them to complete this practice assignment that I've left you guys. It was originally a partner swap. We're not going to be swapping partners, so whatever partner you end up sitting beside, just work with that same person for the entirety of the assignment. I do believe it's 12 questions, so you have 12 questions to answer in the remaining of class. Y'all are going to get a bathroom break, of course, right after we finish this little notes video. And then when you guys come back, work on those 12 questions, use your notes, and then you will turn those in. So you are going to turn those in, and remember it goes in the little file buckets behind my desk on that bookshelf. And my hope is to see you on Friday. Bye, guys.